Welcome to the Petropapers podcast. Say that 10 times fast. This is where you get your oil and gas intellectual stimulation by asking the technical questions. I'm Yogashri Pradhan, and with me here today, I have Derrick Turk. Today, we're going to interview Derrick and learn about his career trajectory and also learn about what kind of advice he'd give to young professionals in making technical contributions to the industry. Welcome to the podcast, Derrick.
Thanks. I'm really happy to be here.
Well, let's get to it. And the first question I really wanted to ask you is how'd you get here? Tell me about
Yep.
your career path.
Yeah. So I think like a lot of kids, maybe from the 90s or maybe just kids in general, obviously what I really wanted to do when I grew up is be a paleontologist because dinosaurs are really, really cool. And then I realized that that involved a lot of days digging, sand in like Montana and it was 110 degrees. And then I decided I wanted to be a fighter jet pilot because jets are really cool. And I realized that number one, I have terrible eyesight. Number two, military discipline is just not for me. And number three, flight simulators are like actually pretty affordable as a hobby. So around, I'll date myself a little bit here. When I was in high school, what I really wanted to do is actually teach computer science. But I also entered high school sort of immediately in the aftermath of the dot-com bust. And so, all the advice I got from friends and family was that this computer thing was played out. Obviously, this was, nothing doing here. And despite a little website called Facebook launching the year I graduated, I decided to go into engineering. And I chose mechanical engineering because I really didn't know what I wanted to do other than, well, I was decent at math and it seemed like the most generic form of engineering, and you could kind of take it a lot of different directions. And a couple of things happened over the course of college. One is I realized that the typical mechanical engineering career trajectory looked like specializing in some specific form of widget. And you might be able to say something cool to your family, like, oh, I work on jet engines. But what that really meant is like you spent 5 years of your life perfecting the metallurgy of like the second left blade on one specific engine. And that was like your thing. And the other was, of course, kind of the Great Recession in '08. And so for a combination of sort of personal and broader, economic factors, long story short, the oil and gas industry was who was hiring in '08. And then I've got some family history in it. So I knew a little bit about it. And, my dad's a petroleum engineer and I've got family kind of on both sides that have worked in the oil field in different capacities. Took an internship with Devon Energy, who's fortunately still around. It was a great company to work for. And what I discovered was that there's actually this whole other world in petroleum engineering of sort of reservoir engineering and economic modeling. And unlike the mechanical engineering world that I kind of learned about in college, an engineer wasn't necessarily just responsible for like the design of a specific widget. An engineer might be responsible for the modeling and sort of design and approval of, multi-million dollar capital projects. And I thought that was really cool, just from a, dinosaurs and fighter jets, right? If it's big and fast and loud and maybe a little bit dangerous, that seems cool to me. And so we checked a lot of those boxes in the industry. So it was kind of an odd path to get there. And I carried a lot of some of the ideas, especially around computer science, which is something I really was very much kind of like wanted to go into with me into the industry. But working as an engineer, I obviously, completed the internship and decided this was a cool company to work for in a good industry and went to work for Devon. First in Houston, then in Oklahoma City, went through their rotation program and learned a lot along the way about sort of the different disciplines and enjoyed the completions and operations side a lot. But what I was really drawn to is kind of the reservoir engineering side, just because it's a little bit more of a what I saw as a big picture and kind of this hybrid of, yeah, there's some math and there's some engineering, but there's also some economic modeling and some more of the business perspective and also a nice opportunity to, bluntly, those are the engineers that tended to write a little bit of code to the extent anyone did back then. And so that kind of became a natural fit for me. I ended up working in new ventures was what Devin called it, which was kind of um, exploration group, right? And so we were looking at things like the Eagle Ford Shale, and don't someone out there's going to remind me of Devin's track record here. I'm just going to say it wasn't my fault. I say go for it. Though I think I was looking at maybe the second or third swing at the bat back there. But again, this was early in the world of oil shale, like 09, 2010. So anyway, found myself working on exploration and specifically like unconventional oil, unconventional gas, shale, horizontal drilling, et cetera, et cetera. Really what's become the norm, obviously, in the US in the last I don't want to do that math. Since I started my career, let's say. Um, and the big problem we hit, needless to say, was that we really didn't have, as reservoir engineers, there's a line from a William Gibson novel I'd mangle if I tried to quote. But long story short, there's kind of two kinds of reservoir engineers, right? There's kind of what I think of as like very technical, and then very maybe high level or kind of financials driven. And we were, to quote William Gibson, we were very technical boys. So we reservoir simulation and numerical modeling and all these things and all these great tools in our toolbox. I thought they were great, coming in as kind of an outsider of the industry, um, or at least not having a petroleum engineering background in school. But the problem we hit is you could not measure any of the inputs, any of the quantities we needed to know to apply those, especially to like, we were looking at things like the Cana Woodford, these kind of greenfield oil shale type plays. And, the best you could do for numerical simulation was kind of this layer cake where you'd mumble something about system permeability based on like a crushed core, and I'm going to mangle the terminology on this because I'm so far out of this world, but I don't think it's really changed. The best you can do to measure system permeability in like a gas shale is you take a core, you bring it up to some wildly different pressure environment, you crush it, you put a pulse of helium through it, which doesn't really resemble the reservoir fluid, and you measure the sort of transient response, and you call that like GRI method system perm. And what the heck that means in terms of the actual rock and its heterogeneity and anisotropy and natural fracturing, I mean, who knows? So we'd build these models, and we had so many degrees of freedom to tune them, and we could history match, but it didn't really tell us much or feel like it told us much. And what I started playing with, and several of us were interested in this at the time, was taking a broader statistical approach to this. What machine learning, or back then we called it AI, because this was still AI is just the term for like whatever's the sort of new thing in computer statistical modeling, right? So AI at the time, which would be things like random forests and kind of multivariate nonlinear models, some neural networks, although the hype hadn't blown up around deep learning or transformers or anything like that yet. And we started producing pretty decent results in terms of being able to, maybe we couldn't explain mechanism, um, but we could make predictions, right? We could say, hey, we can explain 70-80% of the variance in 6-month cumulative or whatever your production target is by looking at these things we could measure, by looking at well placement and rough petrophysics and completion design and whatever it was that we sort of had available that we could reliably measure. And that at least gave us some knobs to turn, right? We could build models and sort of use them interactively, let engineers turn, okay, adjust the fluid loading, plus or minus 10%, adjust the proppant loading plus or minus 10%. What does that response curve do, right? Sort of where do you sit on that like S curve of diminishing returns of like completion size versus production outcome? So that started to be a pretty attractive way to look at things. And this was around the time I think Thomas Davenport put out that article in Harvard Business Review in like 13 that said data science. So it kind of I don't know if he coined the term, but he popularized it and sort of said data science was going to be the sexiest job of the 21st century, and everything was Moneyball. And oh my God. So 2012, 2013, right? It blew up and everyone wanted to be in data science. Um, which sort of led to a bit of gold rush. And I also grabbed my shovel and jumped out independent in 2013 for a lot of reasons around, kind of to oversimplify it, maybe seeing the leverage you could have as a kind of at the time, what we would call a data scientist or data science practitioner in oil and gas by combining some of the engineering domain knowledge with a little bit of statistical knowledge and a decent programming and data management ability. And there's this whole talk I've given at other conferences called like Save the Unicorns, I think, about how that original concept of a data scientist has drifted, and maybe we need to go back to it. I no longer think what we do at Terminus is really data science in the sense that that phrase gets used now. Some of that's because we have changed, some of that's because the industry has changed, and some of that's because the term's been a little bit devalued and commoditized. But I guess to give a very brief recap of life since 2013, I now run Terminus LLC, which is a independent consulting operation. My wife Catherine joined the company in 2020 or 21, I want to say. So she brings a lot of background in the chemical industry and in sort of operations management and even things like, and I'm going to mangle this, predictive maintenance, sort of the whole other worldview you get when you have assets above ground instead of below ground, and you can actually take measurements and sort of run things in a reliable, automated way, and also where the consequences for failure are not merely wasting money, but are like releasing a toxic cloud that, wipes out all of Houston or something. So it's a very different mindset, and she kind of brings that perspective to Terminus, which is cool because it gives us a couple different ways of looking at problems. Um, I we've done a lot of work in a lot of different places since 13, much of which has been in the oil and gas industry, some of which is not. We've worked in kind of the financial world as well as the pure technology world in some different capacities. We have some odd little niches of expertise that don't necessarily fit into the E&P world, but maybe we'll talk about that in a minute. That's kind of my probably overlong career recap.
Well, you definitely have a unique trajectory, Derrick, and it was just
Yeah.
fun listening to all that because, man, we could have crossed paths at Devon too. When,
Yeah.
yeah, because I was interning at the time when you
Yeah.
were working. So that just sounds really cool. Oil and gas is such a small world, but you definitely
Yeah.
have a unique career path, and I can relate to the paleontology and the fighter jet or jet fighter career, that aspiration too at a young age. Well, you mentioned this a little bit, but let's take a deeper dive into it. What exactly does Terminus do, and what kind of projects have you been working on most recently?
Yeah. So we the line I always use, and I've got to stop using it, is we do a little bit of everything. And that's true in a very specific sense. I think a better way to put it is we help organizations solve challenging technical problems. Sometimes that involves writing code, sometimes it does not. We are generalists in a way that is and this kind of goes back to like why we've de-emphasized data science from the branding, because there's been a bit of a commoditization of what people think of when they think of data projects or data science and E&P. And I think people think of dashboards and they think of sort of off-the-shelf software or sort of, oh God, what's the other one? Master data management. And all these things are great and they're necessary. But they're also very commoditized, right? There's some kind of canned workflows that are out there in two or three pieces of off-the-shelf software and you can grab and go. What we are good at and what we try to help people do is come in and solve problems where the solution is not just a matter of we could solve it if we sort of spent more time on it, or we just need more hands, or we just need to throw more money at the problem. We like to help people solve problems that really require a perspective they don't have in-house.
Mm.
And usually what that means is sort of being able to be interdisciplinary in a way that's not common in E&P. Terminus was the Roman god of boundaries and boundary markers. And so we like to think that we sort of sit at a unique boundary between engineering, domain expertise, and software development, and in some cases, statistics and machine learning. But a lot of what we do boils down to spotting opportunities to sort of use solution techniques that are maybe outside the sort of typical repertoire in E&P. So good example of how kind of like computer science and oil and gas knowledge kind of intersect to solve problems in ways that are not obvious, maybe inside the typical E&P organization, is managing, and this has come up a couple of years ago, and actually for a current client has come up as well. Reservoir engineers live in like one of two or three different software suites for doing reserves analysis, right? And so, PEEP, Aries,
Yeah.
PhD Win. I say PEEP first. Probably no one's heard of PEEP. That was a Devin thing. Devin loved
The
PEEP.
Devon thing.
Yeah. So I learned PEEP, which was a totally useless career dead end. Sorry, I'm not trying to make a commercial. I mean, I'm not, I don't have I'm not in that world anymore. Aries is obviously, it got a little bit more market share but they've all got some commonalities and a lot of companies right now have the problem of trying to translate either between those tools, either because they're building software to help people do things like forecasts or reserves analysis, or, you're in-house at an operator and you've got something like, hey, we need to plumb, say Aries output into our portfolio modeling tool. And we'd like to do some validation along the way, basically do our models make sense? And all these tools, because of the way they evolved over time and the problems they have to solve are so complex that they really actually kind of embed what amounts to a programming language. Like if you look at Aries economic lines, it's got its own syntax, it's got its own um, sort of grammar, right? All these things you can do in Aries economic lines, and everyone who engineers, petroleum engineers that want to deal with Aries economic lines, they just dump them into Excel and okay, maybe I can like string split this or put it in this column or like search for this, and it won't work. It fundamentally won't work. And there's actually well there's kind of real theoretical mathematical reasons it can't work. Um, but what it comes down to is it's just not the right tool for solving a programming language parsing problem, and that's what it is. And so, if you treat it as like, hey, this is a programming language and we're going to parse it, you realize that we've actually got in computer science a body of knowledge going back to, let's see, Fortran was what, 50, 54, 58.
Mhm.
So that would be 50, 60, 70 years body of knowledge on sort of how to parse formal grammars into data structures and manipulate them. And, and so, for instance, for a client, we were able to sort of come in and actually build a proper parser that handled Aries economic lines. And then, once you kind of got the Aries economic parser, now you've got your econ lines translated from sort of unstructured text to nice data structures, and you can actually write all your validation in a very similar way that a programmer, a computer scientist might write a compiler, as sort of passes over these syntax trees. And anyway, that's way down in the weeds. But what I'm trying to convey, and probably have done it poorly, which is why I'm never good at this question, is we really do look for opportunities to sort of solve problems that are, if not insoluble, sort of with kind of the standard E&P toolkit, are at least very, very challenging, sort of wicked problems, right? I think is the old science term for them. And it's not uncommon that we'll come in, and another pretty typical thing is maybe an engineer has thought through a workflow and written some code to automate it, which is great. And it's already saving the company a ton of money or time or both. Um, but we can come in and take a look and say, hey, like, we can move this into a database. We can, we can identify these opportunities for speed up. We can identify these opportunities to simplify it. And it's not uncommon to kind of walk away with something that's literally 100 to 1,000 times faster and take like an overnight process to a 5-minute process. Or I always think in terms of, I actually do think time is money in software, and so I always think in terms of orders of magnitude of like, blink of an eye, coffee break, lunch break, overnight, right? And if I can take overnight to lunch break, or take lunch break to coffee break, or take coffee break to blink of an eye, I can speed up that engineer's it's actually like not just a quantitative, it's a qualitative difference, right? Because of the way humans get distracted. If I can take something from taking even like 3 seconds down to 30, 300 milliseconds, now that's gone from a workflow where you hit it, it spins, you get bored, you alt tab, you check Facebook, to a workflow where you hit it, you see the result instantly, you iterate. And so kind of like I mentioned earlier, we've got some odd little niches of expertise. We do things a lot of people don't do these days. One of those is write sort of high performance software, compiled programming languages. We parallel processing, and we've got some tricks that are sort of becoming less and less common as computers get faster and things kind of standardize on like the Python slash JavaScript stack, which is a engineering disaster, but that's a whole other conversation.
That sounds really interesting, and love the different niches or love the different descriptions of what you guys do. And it sounds very exciting. Yeah, this endeavor really does sound exciting. Speaking of the different niches and the functions that you talked about,
Mhm.
wanted to pivot a little bit to young professionals, those that are listening to this podcast and listening to you really and hearing about your perspective. What kind of advice would you give to them in order to make technical contributions to the industry? Because you made quite a few technical contributions to the industry.
Yeah, thanks. Well, yeah, so first kind of a disclaimer. I'm not a prolific SPE author. I think my last paper I was a co-author on was like 2015. And I think, Terminus, we on kind of the old spectrum of like physicist to engineer to mechanic, we certainly aim to be engineers and sometimes mechanics. We're not necessarily out in the business of doing new research in any of the fields that we sort of sit in. But what we try to do is sort of bring novel applications, right? We're trying to live in the applied sciences and look for ideas where we can sort of bring this idea from computer science and this idea from reservoir engineering and maybe help someone be the first to put them together in a way that really makes a difference in their business. And so I think, and my caveat is just so nothing I say here is necessarily going to apply to the world of sort of research state of the art, right? That's a whole other ball game. But when it comes to sort of moving the needle technically in the oil and gas industry or any industry, I think there's two parts, and the first part's easier than the second. The first part's the technical part, and to me, the key there is just it's relentless curiosity, and it's believing that you can always drill down and sort of find the answer, and not being afraid to drill into the details. There's nothing I can say that probably isn't said better by like Richard Feynman or some of the famous physicists from the 50s, and then they're a lot more eloquent than I am. Short version would be juggle a lot of problems in your head all the time and sort of look for these cool opportunities where like, oh, hey, this thing I learned about this problem actually applies to that problem too. It makes you look like a wizard, but there's really no magic to it. And that's kind of what our catchwords is. There's no magic. It's just engineering. It's just digging in and even in the software development side, realizing that the libraries and the things you build on, that's just code, and you can drill in and read that code. I think Feynman has a line from one of he's quoting an old math textbook, but it's like anything one fool can do, another fool can do too, and that's all it comes down to is just kind of being willing to believe that you can do it and put it through. So that's kind of touchy feely stuff on the technical side, but it's true. The harder side is obviously the people side and the organizational side, and the kind of stock advice, and it's true, is you've got to be able to sell the value of your work and communicate the value of your work. That's true. That's absolutely true. I think communication skills are really important for engineers. I'm going to take a little bit more maybe cynical tack and say too, though, that there's sometimes you really are in a situation where the technical work is just not valued, or for one reason or another. And one thing the data science world is prone to, unfortunately, is like kind of check the box thinking, where the mandate comes down from on high that data science must be done. We must have machine learning. We must have AI. And the magic phrase you'll hear is something like, "Well, we don't care if the numbers are right. We just need numbers. We just want to see numbers. We just see results." And I'm going to tell you I have the luxury as a consultant and I use it from time to time of hopefully not firing clients, but in some cases of turning down work, because it's just not going to be a meeting of the minds. I can't get myself in that mindset. And I think sometimes, you know, I, good or bad, maybe my advice is if you truly find yourself in a situation where you've tried to communicate the value of what you're doing and you really believe it's got value. There's kind of an old saying, and I can't think who coined it from one of the programming career writers. It's like sometimes you reach a point where you can either change your organization or change your organization, and sometimes it's time to change your organization. It's you can spend a lot of years ramming your head against a brick wall. I think if you find people who believe in the possibility of there being value in technical work, and I'm not overly cynical on this. There's a lot of people that want to do good work, And it really is just a matter of communicating how it achieves, you know, a meaningful result for the business or the organization. But you do sometimes run into the check the box thing, and it's my message is maybe like you're not crazy. It really is out there, and sometimes you just have to either route around it or accept that it's not gonna happen in certain circumstances.
Well, I appreciate the advice. There was one more question I wanted to ask you before I let you go, and
Yeah.
it is, what motivates you to solve oil and gas problems or even data science problems?
Yeah, so I like the nice clicky sound as solutions come together. There's I kind of we I like to think in programming there's kind of like two well, I mean there's never just two, but I'm an old kind of wannabe liberal arts major, and so I want everything to be a duality, a thesis and antithesis and a synthesis. And so I perceive that and I'm going to talk more about programming. I think it applies to any kind of technical endeavor. I think there's kind of two approaches people take, and if I were being really pretentious, I'd say they're like the Apollonian and the Dionysian approach. And there's kind of one is a very analytical, structured, top-down, design engineering approach, and the others like throw things at the wall and see what sticks.
Yeah.
And frankly, the last 10, 20 years in software have been much more Dionysian. They've been much more like, what's the Silicon Valley of? Move fast and break things, right?
Mhm.
I don't like moving fast and breaking things. I like sitting down and thinking about problems. And I get a lot of joy out of the feeling of sort of taking a challenging, complex technical problem and sort of boiling it down to it's actually almost a mathematical approach, right? To kind of like finding what are kind of the key parts of this thing we're talking about and how do they fit together, right? Like if I can turn it into like the nouns of this system are x's, y's, and z's. And if you have two x's, you get a y, and you can turn a y and an x into a z. Um, the whole pipeline for me is like do that modeling, turn that into data structures, whether that's, database tables or data types in a programming language or both and some mapping. And then kind of like literally in my head, it's like, I mean, you may see behind me, my toddler loves Legos. I think it's probably genetic. Um, but it really is, I have a lot of fun sort of finding the small moving parts of a problem and then assembling them together into a solution. And so, kind of buzzwords of how we think about things, a lot of statically typed programming languages, a lot of oh, we do a lot of kind of relational data modeling, and we try very hard to do some good buzzword like push data validation to the point of entry. And so we end up with these very um we like building constraint systems. We're believers in like the kind of constraints breed creativity in some ways, and looking for tools that sort of help programmers impose limits on their own creativity in the interest of correctness, which is kind of an odd and maybe engineering oriented approach to software, but that's the sort of stuff that I personally enjoy. And I suppose I'm supposed to say that the kind of stock answer of like, I love watching engineers' eyes light up as they discover that the tool like enables their, which I do, it's fun, but for us, it is a lot really is just kind of the joy of the solution and of the problem solving. That's kind of something we've always enjoyed.
Well, that's awesome. Well, Derrick, thank you so much for your time today.
Yeah, thanks. I really enjoyed it.
Well, folks, you could listen to Derrick's interview on Apple Podcasts and the YouTube channel. Be sure to check out Terminus Data Science, and I'll have the link of the Terminus Data Science website below in Apple Podcasts and on the YouTube channel. This is Yoshi Pradhan, and we're signing off.
Thanks.